Introduction. The potential impact of Sunspot AR3664. A sunspot has grown so large that it could have catastrophic consequences. The size of sunspot number AR3664 is increasingly resembling the Carrington sunspot, which in 1859 was the harbinger of an apocalyptic particle storm that put the USA in a state of emergency for weeks. Description of sunspot AR3664. The gigantic spot, now visible on the surface of the Sun, is already 15 times wider than our Earth at 200,000 km in length and continues to grow. This raises the question, could an event similar to the one in 1859 happen again, potentially causing our civilization to collapse within minutes? Understanding sunspots. AR3664 is one of the largest and most active sunspots in the current solar cycle. Sunspots are areas on the Sun's surface caused by intense magnetic activity, appearing darker due to their lower temperature about 1,500 Kelvin cooler than their surroundings. Potential consequences of solar storms. These magnetic anomalies can lead to solar flares and coronal mass ejections, releasing enormous electromagnetic radiation. Such events have the potential to bring our modern civilization to a standstill by disrupting power grids and communication systems globally. Recent activity and observations. AR3664 has already produced several significant flares, leading to unusual atmospheric phenomena like auroras visible far from their typical locations. While the effects so far have been mesmerizing light shows, the threat of more severe impacts looms. Observing sunspots. Despite the risks, observing sunspots like AR3664 can be done safely with specially certified solar eclipse glasses. This allows us to witness firsthand the immense scale of these magnetic disturbances. Scientific context and implications. Such large sunspots indicate intense magnetic field concentrations, which are critical areas for scientific study to understand their potential impacts on Earth's magnetic environment. Historical perspective. The Carrington event. Reflecting on history, the Carrington event of 1859 serves as a stark reminder of the vulnerability of our modern technological infrastructure to solar storms. Richard Carrington's observations correctly identified the solar storm's cause, which disrupted early electrical and communication systems. Conclusion. A cautionary tale. The Carrington event remains a cautionary tale of how vulnerable our civilization can be to the Sun's fury. As we continue to monitor AR3664 and similar phenomena, the need for preparedness and understanding grows more urgent. Historical impact. The Carrington event. The Carrington event peaked on September 1st and 2nd, 1859, but its aftermath, with fiery skies, lasted for weeks. The USA was particularly affected, with telegraph stations continuing to send messages even without batteries, powered solely by the geomagnetic storm. Elsewhere, electric shocks from telegraphs set paper on fire, illustrating the intensity of the solar storm. Scale of the Carrington event. The sunspot observed by Carrington was exceptionally large, though exact dimensions aren't documented. The massive coronal ejection he witnessed hit Earth in just 17.6 hours. At the time, humanity's technological advancement meant the impact was relatively mild compared to today. Modern vulnerabilities. Today, events like the Carrington event could cripple our power supply, leading to widespread system collapses within days. Emergency generators might sustain critical systems briefly, but prolonged outages could lead to food spoilage, ATM failures, and communication breakdowns. Potential consequences. Satellites essential for communication, weather forecasting, and navigation could be damaged, causing global disruptions lasting weeks or months. Aircraft, ship, and car navigation systems might fail, leading to accidents. A study estimates such an event could cost the USA up to $26 trillion and trigger a global crisis. Current threats. Sunspot AR3664. Sunspot AR3664 has already produced significant M-class and X-class solar flares, some of which have impacted Earth. These flares occur when magnetic fields in sunspots release large amounts of energy, causing short-term radio blackouts and triggering geomagnetic storms that produce visible auroras. Understanding solar flares. M-class flares are 10 times stronger than C-class flares, while X-class flares are the most powerful, capable of severe outages if they hit Earth directly. While we've been fortunate so far, experts warn, it's only a matter of time before a violent X-class flare challenges our global security. Public awareness and preparedness. Surveys show that many are unaware of the potential dangers posed by solar storms. The lack of historical precedents in modern civilization leads to complacency. However, having emergency supplies of food, water, and cash can mitigate the impact of such events on individuals and communities. Mitigation and preparedness efforts. In the event of supply network failures, being prepared to manage without shopping or access to money for at least a week is crucial. Researchers and governments worldwide are actively working to protect us. Enhanced monitoring of the sun, particularly during the appearance of sunspots like AR3664, allows global observatories to issue timely warnings to governments, airlines, satellite operators, and electricity companies. Global cooperation and strategies. International cooperation is key, with experts developing strategies to safeguard global infrastructures and power grids from solar flares and their effects. These include upgrading power line facilities, building resilient satellites, establishing emergency communication networks, and developing technologies to mitigate electromagnetic fluctuations. Role of NASA's Solar Dynamics Observatory. The NASA Solar Dynamics Observatory SDO, launched in 2010, plays a pivotal role in monitoring the sun. It provides high-resolution images and continuous data on solar activity, observing the sun at various wavelengths to enhance our understanding of events like solar flares and coronal mass ejections. This intensive monitoring has facilitated the creation of detailed maps and improved predictions of solar activity cycles. Challenges and future preparedness. Despite advancements, the unpredictability of solar flares raises questions about our readiness in an emergency. Solar flares can erupt suddenly and reach Earth within half an hour, leaving minimal time to secure power grids or adjust flight plans. Subscribe and stay informed. Subscribe to our channel to stay updated on developments in solar activity, preparedness strategies, and ongoing efforts to protect our global infrastructure.